I'm going to give a quick overview of 3DVH and the powerful tools you can use to do your analysis of dose QA. I first want to remind you that the way we conventionally do dose QA now is based on passing rates of dose in a phantom, and I'll talk a little bit more about that later, but wouldn't it be nice if we actually knew the impact of any imperfections in dose that we could or couldn't detect with conventional methods? So what you're looking at now is the 3DVH analysis interface. I've already run a PDP calculation to estimate the actual dose to the patient, or the corrected dose to the patient. And what you're going to see here is 3DVH is a lot like a very, very powerful plan comparison tool. And in fact, 3DVH also can be used as a universal plan comparison tool to compare plans from any modality, treatment planning system, etc. What you're looking at here is the treatment planning system planned dose calculated by the planning system. And then here's the PDP estimation. Now looking at the dose clouds, you can't tell much difference, but you can run a comparison. Comparison lets you really see where differences in dose might occur in the anatomy. Here you see a dose difference histogram in the lower right, and now you're seeing a dose difference map. Some tools you can use to scale up, pan, and zoom. It's all fully interactive and three-dimensional, just like you would expect a plan comparison tool to be. But really the most powerful metrics come from our DVH, don't they? We want to see what the clinically relevant changes are. So we can analyze just a few select DVHs, some of the target volumes, some of the critical structures, and you can see in this case they're extremely close. A little bit of deviation though in that very small structure. The DVH is fully interactive, so you can sample any volume percent and get the corresponding dose values of whatever DVHs you're sampling. Or you can type in an exact dose value you want to sample. You can do the same thing on the dose axis, so that you can get quickly any volume percent at any specific dose. So you can readily find the D95, etc., whatever metrics you're looking at. Very powerful in 3DVH is something called the quick stats. You can set up any number of quick stats. I'll show you that real quick. These are the results of the quick stats, and you can set these up. Any number you can set up points off of DVH that you always want to see per organ. So for example, in this case, in the CTV, I wanted to see the D95 and the D1. On the heart, I wanted to see the V15 and the V30. Spinal cord, I wanted to see the max dose. And here I have D1%. But this is actually a great example. Let me show you how these were set up. If I go to quick stat defaults, if I go down and find my spinal cord, you can see I really want the dose at 1 cubic centimeter. So I can quickly save that, and now you'll see my quick stats for the spinal cord. I'm getting the dose to 1 cubic centimeter, which is extremely valuable if you're doing things like RTOG, clinical protocols, etc. You can also analyze by structure. So if you wanted to get the actual number of high voxels, number of low voxels per structure, you can do that. It's a purely volumetric, goes through the entire density of the patient and gives you these pass rates. Again, pass rates are kind of hit and miss because you can have very high errors in a low volume, and that may be clinically relevant. But this is a nice tool if you're just looking for differences. So if I want to look at dose differences here, there are almost none in the CTV, but if I go over and maybe examine the left lung, I can go in and sample the values of these high dose voxels wherever they appear red. You can also go back and say, if you had some errors, you could figure out what might be causing these. So we actually show you the conventional planar QA. These are the measured dose planes and the calculated dose planes from the planning system in a flat phantom. Of course, this is what drives the PDP algorithm for static gantry angle IMRT. I'll talk a lot more about that later, but you can see here it's an interactive map, and you can go to any of the beams, quickly navigate. You can see these profiles are matched very well, which is probably why the DVHs and the patient dose matched so well. So those are just a few of the tools. You can go back to the 3D dose. Very useful tool is the measure tool, where not only does it measure the point-to-point distance, but it also shows you a dose profile along whatever hypotenuse line you're drawing. So here you see an interactive dose profile, and you can see the dose profiles inside the patient by sampling any one of those views. So there's variety of drill down tools you can use. This is just a very small number of the tools, but now you can see your dose QA will no longer be based on passing rates of gamma in a phantom, which may or may not have any meaning. And like I said, I'll talk about that in the next section. Now they'll be based on patient dose, dose volume histogram, the type of metrics you approved the plan with in the first place.